In this video, we're going to apply the fundamental theorem of calculus to look at the difference between displacement and distance. So here we have a skateboarder that travels along a road such that its velocity at time t is given by v of t is equal to t squared minus 4t plus 3 meters per second during the time interval between 1 and 4 seconds. Part A, find the displacement of the skateboarder over the time interval 1 to 4. Part B, find the total distance traveled during this time interval. For part A, we're going to need a displacement. The displacement is just going to be the definite integral from time 1 to time 2, integrate the velocity function. That gives us the displacement. For part B, we need the distance. The distance is going to be integral from t1 to t2, but here's a key distinction. We have to use the absolute value of the velocity. All right, let's look at part A. So the displacement is integral from t1 to t2 v of t dt. Displacement is equal to integral from 1 to 4 t squared minus 4t plus 3 dt. Let's integrate term by term. Integral of t squared is t cubed over 3. Integral of 4t, that's going to be 4t squared divided by 2, reversing the power rule here. And antiderivative of 3 will be 3t, evaluated from 1 to 4. Let's put the upper limit in, and we get 4 cubed divided by 3 minus 4 over 2 is 2, so we get 2 times 4 squared plus 3 times 4 minus, putting the lower limit in, we get 1/3 minus 4 over 2, that's 2, plus 3 times 1, that's 3. Let's simplify further. We get 64 over 3 minus 4 squared is 16 times 2, that's 32. 4 times 3, that's 12. Distribute the minus sign, minus 1/3 plus 2 minus 3. Now 64 over 3 minus 1 over 3, that's going to be 63 divided by 3. And minus 32 plus 12, well, 12 minus 32, that's minus 20. And 2 minus 3 is minus 1. So we get 63 over 3 minus 21. And write this over 1 and take a common denominator. 3 goes into 3 one time, we get 63, minus 3 goes into 1 3 times 21 is 63. That's equal to 0. Therefore, we can say that the skateboarder has a net change in position of 0 meters. All right, let's look at part B. In part B, we have the velocity is t squared minus 4t plus 3, and our goal is to find the distance. The first thing we need to do is to change the absolute value in such a way that we can get rid of the absolute value. So absolute value of v of t is going to be minus t squared minus 4t plus 3 when t is between 3 and 1. Why is that? Why are we putting a negative in front of the velocity? The reason is because we want to simulate the effect of the absolute value. So in a time interval between 1 and 3, the velocity function dips below the horizontal time axis, so we have to put a negative in the front. And when time is between 4 and 3, the absolute value of v of t is just going to be itself t squared minus 4t plus 3. All right, now we can do the integration. Distance is equal to integral from 1 to 4. I'm going to pull out the minus in the front. That's t squared minus 4t plus 3, all integrated with respect to time, plus integral from 3 to 4, t squared minus 4t plus 3. So we split up the integral into two separate integrals on two separate time intervals. So now let's integrate. We get minus integral of t squared is t cubed over 3 minus 4t squared over 2 plus integral of 3 is 3t, all evaluated from 1 to 3, plus the second integral of t squared is t cubed over 3 minus 4t squared over 2 plus 3t, evaluated from time 3 to 4. And now plugging the upper and lower limit in, we get minus 3 cubed is 27 over 3 is 9, minus 3 squared is 9 times 2, that's 18, plus 3 times 3 is 9, minus, putting 1 in, we get 1/3, minus 2 plus 3. Close the bracket and close the square bracket, plus, Put 4 in, we get 64 over 3. Minus 4 squared is 16 times 2, that's 32. Plus 4 times 3 is 12. Minus, put the 3 in, 3 cubed is 27 over 3 is 9. Minus 3 squared is 9 times 2 is 18. Plus 3 times 3 is 9. Close the bracket. Alright, so what we have is this above expression, and we need to simplify this. Distance is going to be equal to minus 27 over 3 is 9, minus 18, plus 9. Distribute the minus 1/3, plus 2, minus 3, close the bracket, plus 64 over 3, minus 32, plus 12. Distribute the minus, we get minus 9, plus 18, minus 9. So let's distribute the minus. We get minus, here we have 9 minus 18 is minus 9 plus 9. So this all is going to cancel out to 0. And 2 minus 3 is negative 1 minus 1/3. That's minus 3 over 3 minus 1 over 3. That is negative 4 over 3. Plus, and here we have 64 over 3. And 12 minus 32 is minus 20. 18 minus 9 is 9 minus 9. That's all going to cancel out to 0. So the distance is going to be 4/3 plus 64 over 3 minus 20 over 1. So that's going to be 68 over 3 minus 20 over 1. Common denominator of 3. 3 goes into 3 one time, that's 68. 3 goes into 1 3 times 20, that's 60. The answer is 8 over 3 meters. This is the distance traveled by the skateboarder over the time interval 1 to 4. So let's do a little bit of review. In part A, we found the displacement using the formula integral from 1 to 4, v of t dt. Part B, to find the distance, the key distinction here is we integrate from 1 to 4, but we need to put absolute value of the velocity function, absolute value of v of t dt. And that came out to be 8/3 meters for the distance, and for the displacement, it came out to be 0 meters. All right, thanks. I need to make a correction to this video. In part B, when we were evaluating the total distance traveled, the first integral, the limits of integration has to be from 1 to 3. So let's change that. 1, 2, 3. All right. Thanks.